Here we'll determine the domain and range of piecewise graphs. Now this is a piecewise graph because we have a red function and a blue function, which are separate pieces. I've entered their graphs here. Y equals x plus 3 is the red piece, and this red piece is for any x's that are less than 0, as indicated by these symbols inside of the curly braces. After 0, we switch to the blue piece, which is for all x's greater than 0, and the graph that we use for the blue piece is negative x squared. So at 0, we are switching graphs. Now to find the domain, let's look along the x-axis. On the left side of the x-axis, we have a left arrow. That left arrow, as we know, symbolizes negative infinity. On the right side, for the blue function, we also have a right arrow. We know right arrows symbolize positive infinity. However, in the middle, we do have a place where the functions switch, and we have to be careful about our domain at that position. I'm going to mark that position with a blue line. Notice that at that position I've drawn, that is where x equals 0, and at x equals 0, I have two open circles. Anytime you have an overlap between two pieces, but all of the circles are open, that creates a break in the domain. I'll draw a picture to symbolize that next to the domain here. Our left arrow gives us negative infinity, and our right arrow gives us infinity. However, we're going to put an open circle at 0. That open circle creates a break in the domain, which I'm going to symbolize with this solid line. That's going to separate the domain into two pieces. Piece A to the left of that break, and piece B to the right of the break. For the domain, I'll write for A, negative infinity to 0. Now for 0, since all of our circles are open, we're going to put a parenthesis there to show that 0 is not included. We can think of open circles as being matched up with parentheses when we write our domain or range. We'll then say union because there's another piece coming. Piece B will also go from 0 to infinity. Of course, reading left to right as usual. Infinity always gets a parenthesis, and because all the circles at 0 are open, we'll put a parenthesis around 0 for piece B as well. Now let's try to draw our range. The range will be a little bit more complicated since we have to incorporate two pieces. Let's start by trying to look at the red piece. For the red piece, we do have a diagonal downward arrow. That diagonal downward arrow represents negative infinity when it comes to range. If we follow the piece upward, that piece will stop at this open circle. We'll make a note that that is open, and that is halfway between 4 and 2, which is a value of 3. We'll represent that on a picture representing the range, having an arrow going up and down. We're going to mark this in red and show that we do have a down arrow, which represents negative infinity. This piece continues upward and stops in an open circle at y equals 3. Then we look to the blue piece. That blue piece also has a down arrow, and that down arrow represents negative infinity. If we follow that piece upward, reading from bottom to top, the blue graph stops at y equals 0, which is also open. So we'll also draw a blue line starting from negative infinity, but this time stopping at 0 in an open circle. So we have a function going from negative infinity to 3, and another one going from negative infinity to 0. When it comes to the range, the function that covers more y value takes precedence. We can see that the functions overlap below 0, which I'm symbolizing with these orange marks. That will definitely be part of the range. However, when the blue function ends, we can always just switch to the red function and continue upward. Therefore, our range will be both functions up until 0, and then just the red function up until 3, and then there's nothing above 3 on the graph. So once again, follow the overlap until 0, and then just continue with the red function until you hit 3. Therefore, we can say that our range starts from -infinity. We're not going to have a break at 0 because we can hop over to the red function and continue all the way up to 3. And since that 3 is an open circle, we're going to put parentheses after the 3. Now let's look for f at -2. We'll mark -2 on the graph and draw a line either upward or downward. Notice that we hit the red function and miss the blue function. That's perfectly fine. We're just going to read the y value on the red function. Notice that this is halfway between 0 and 2. Halfway between 0 and 2 is just 1. And so we'll say f at -2 is 1. We'll do the same thing at f at 2. Circle where 2 is. We'll mark where that crosses the graph, and this time we don't hit the red graph, we hit the blue graph. That's perfectly fine. We can just read what the y value is for the blue graph at that position. We end up with a y value at -4 here. So we'll say f at 2 is -4. If you're asked for f0, we'll look for x equals 0 on the graph. Notice that at 0, we have only open circles. The red is open and the blue is open. Anytime you have all open circles, we can say there is no y value, and f0 would be does not exist, or DNE. We can also do the horizontal and vertical line test on a piecewise function. First, we check if it's a function by doing the vertical line test. We can see if we draw a vertical line through anywhere on the red piece, we're only going to cross it one time. We can see that's also going to be the same for the blue piece. The place we have to watch is the place where they overlap. Here at 0, we can see we're passing through 2 open circles. In a previous video, we said passing through 2 closed circles made it not a function, but the reason why is because the open circles do not count. Because both circles are open, this means that effectively we've passed through the function 0 times. It turns out passing through 0 times does not fail the vertical line test. Therefore, this is a function. However, let's check if it's one-to-one. Now we'll clear off the vertical lines and start drawing horizontal ones. If we draw a horizontal line through this part of the red piece that I'm marking, you can see it only crosses through once. However, if we go further down, we can see there is a place where we can draw a horizontal line that crosses through both the red and the blue. Since we have effectively failed the horizontal line test somewhere, this means that it's not one-to-one. Therefore, in this case, we do have a function because it passes the vertical line test, but we fail the horizontal line test for part of the graph. And again, if we fail the test anywhere, we've failed it everywhere.